Hey everybody, it's Shaban, and today we're going to be talking about components and how they relate to games and game programming patterns. Okay, so components, you may have heard the term component before. It kind of is this term that is used in a lot of different places of programming, so it really depends on the context. But when we're talking about games, components are often used when we talk about a couple of different concepts, right? So you may have heard entity component system, or ECS. This is not what we're talking about today, okay? So we're not talking about entity component system. We'll save that for another video. However, you may have heard it being called in other things, like there might be an entity component model. It's like the model of programming associated with entities and components, or as I might be describing it, the component design pattern. Right, and we're talking specifically how it pertains to games. In order to be able to understand components, though, we have to kind of jump back a little bit to just basic object-oriented programming. So a long time ago, it wasn't that long ago actually, object-oriented programming came around, and everyone got super excited about this cool new idea called inheritance. This was going to solve all of our problems. With encapsulation, with code reuse. We were going to be able to create objects of different types, and those different types can derive from other types. So to just kind of talk about it as an example, let's say that we are creating an application that has animals, right? So there are all sorts of different animals, right? This is like Animal Crossing. Not really, but let's say that we've got different animals, and every animal has certain characteristics, certain traits, or let's call them properties, and each animal also has shares the same certain behaviors. So, for example, animals, they all have some kind of age, right? So they've got some amount of age. Also, all animals have, a weight, some basic stuff like that. And also, animals have like it is alive state, right? They can be alive or dead. But what are some behaviors, some actions that all animals share? All animals die, right? Each of them have a way to die. So let's say that they all die. And of course, there are probably other examples, but I'm not going to belabor it, right? So we have this base class, this animal class from which all animals, different types of animals derive, right? And so I'll even draw a rectangle. Whoopsie, that's an eraser. All right, let's draw a rectangle around it. Beautiful. And okay, but what else? What other kind of animals are there? Well, I mean, if you were to ask someone like, "Oh, name animals," and one of the first things that'll come to mind, of course, is like a cat, right? And so cats, like, how are they, different than other animals? Look, I'm not a, whatever you even call them, I don't even know what to call it, like a taxonomy expert or something like that. What do cats, they have a way, they can scratch. Like all cats scratch. They have to have some way of retracting their claws, retract the claws. They're kind of fun stuff that cats can do. They all, Neato. Cat. Fun. Okay, but yeah, and then there are different kinds of cats, right? Right, so you got the house cat. I guess it's called a domestic cat. Whatever, who cares? And let's say there are also other kinds of cats, like panthers, right? So you got a panther. And so, remember, I'm not an expert on this, on cats, right? And I forget about house cats for now, right? Because whatever, they're okay. Well, cool. So let's focus on panthers here, because panthers have a characteristic that other cats don't, and panthers can roar, right? Because no other kinds of cats can roar, only panthers can roar. Right? And so you've got different kinds of panthers, like a lion. Oops, why am I writing that? We have a lion, and then we have and then we have what other type? Tiger, right? So lions and tigers, they can roar because they're panthers. Now, if some of you know a lot more about cats and you're like, what are you talking about? Like, tigers aren't panthers. We're going with it, okay? Right? So tigers and lions, they're panthers, right? So let me draw some lines here so that like we're clear what's going on here. Beautiful. I'm so good at these lines. All right. So neat. And so this is awesome because we're able to avoid reusing all sorts of code. So tigers, lions, panthers, house cats, all cats, they can die, right? And so we're not having to write the die functionality necessarily for every single class, for every derived class here, because they're all animals and they can just call that die method that belongs to its ancestor way above. And they can do that because they're an animal. And that's pretty cool. And that follows basic principles such as solid. You may have heard of solid. That again is probably going to be saved for another video. But this generally works. But then let's talk about where some of the pitfalls are. So when we ask someone to name an animal, people are going to say cats, and then other people are going to say, of course, dinosaurs. So dinosaur, right? And so dinosaurs, I'm not gonna belabor this. So like you can imagine the kinds of things that dinosaurs can do. So I'm just going to write the dinosaur, and we're going to go with it. And then there are different kinds of dinosaurs, right? There's the long-necked ones, and then there's the short-necked ones, and I think that's about it. No, but let's say that we want to create a T-Rex, right? T-Rex, Tyrannosaurus Rex. And here's the thing about the T-Rex, is the T-Rex is a dinosaur, but a T-Rex can roar, right? I think they proved that by using the Farmer's Almanac or something like that. The T-Rexes can roar, in fact, and so we got a problem because we were talking about this code reuse thing. And panthers are the type of animals that can roar, but let's say T-Rexes can roar exactly the same way that panthers can roar. And for some reason, let's say that this ability to roar is an incredibly complex, like, multi-line algorithm that has to do, with our animals. So it would be nice if we wouldn't have to retype roar, inside of the T-Rex. That would be problematic, especially since there are perhaps other animals that can roar. So how do we solve that problem, right? So we can first do this number. Beautiful. And it extends dinosaur, and animal goes straight to dinosaur. Very good. How do we solve that problem? So there's a couple of different solutions that might be brought to the table. Some might say, oh, well, why don't you create an interface, right? We'll create an interface called, like I can roar. I can roar. But really it's interface can roar, right? So we got this interface, and we can say like, ta-da! And then the interface here, both panthers and T-Rexes both implement this I can roar interface. And that solves all of our problems, right? Well, actually it didn't solve any of the problems I just talked about. Because sure, while you're creating that contract, that panthers and T-Rexes have to implement this roar method, you're still gonna have to implement it, right? You're still gonna have to write that roar method in both places, and you suddenly didn't really solve anything. However, you did solve some of the problems, right? You're able to kind of abstract that idea of roaring to some other kind of idea. But it doesn't solve the problem that we were talking about with code reuse. So let's go ahead and throw this away. Just like, woo, get out of here. Neat. So instead, someone thought, okay, here's how we solve all of these types of problems. We are going to create what is called multiple inheritance. multiple inheritance. Some of you may have heard of multiple inheritance. Multiple inheritance, in this particular example, would mean that our T-Rex both derives from dinosaur, right? And it also derives from panther, right? So I guess I don't never know which way to point the arrows. Like T-Rex derives from dinosaur, or anyways, it's like immigration versus emigration. Well, whatever, you get the idea. T-Rexes are can roar because not all dinosaurs can roar. It'll get all the characteristics of dinosaur, but instead of having to rewrite this whole roar method, we're just gonna grab it by inheriting from panther, right? This solves our problems. Well, it does actually solve the problem with having to rewrite the roar method, but here's the problem. This actually is a very much frowned upon strategy in code architecture for a bunch of different reasons, and many of them have to do with solid, and we're not going to be covering those, but at least just something that you can explain to a 6-year-old is that a T-Rex is a dinosaur, but a T-Rex is not a panther. Okay, so we messed up that identity principle where a T-Rex with multiple inheritance implies that the T-Rex is a panther, which means that the T-Rex is now also getting all of the characteristics of panther, which aren't even accurate, right? So it's not even true. Panther does not have retractable claws, I don't think, and so that's violating the characteristics of T-Rex and the whole idea of this inheritance model. So we've broken that just because we wanted to eliminate code reuse. Now, we really are trying to avoid code reuse, right? That is something we are trying to avoid, but we've messed it up in the process, right? And so that's one issue that we are talking about, that we're dealing with this multiple inheritance issue. The other one that some of you may have heard of when you're learned about object-oriented programming is this, oh gosh, how do you spell it? Diamond, dirty diamond, deadly diamond, super diamond of death. You know, you've heard this before. The deadly diamond, which it says where you create kind of like a diamond structure in your code, right? So it's kind of like this like inverted diamond type of thing, right? It's an animal, and it's a dinosaur, but also a panther, and it's, you know, and then it comes back here, T-Rex. So the problem with that, of course, is there's a bunch of different issues, right? So if cats have some way of scratching, and for some, let's say that dinosaurs have some way of scratching, right? So we've got, you know, like scratch over here somewhere, like who knows, some other kind of scratch happening up here. I don't know how a T-Rex is going to scratch with its little claws, but whatever. But the point is that if it needs to scratch, like whose scratch is it taking, right? So if it needs to call that scratch method, whose scratch? So we've created this ambiguity, and that's a huge problem. So we want to avoid this deadly diamond type of situation. In fact, there's a lot of problems here, and so and this isn't just something like this one-off kind of problem. This is very common when we talk about these kinds of complex inheritance structures, that you run into these issues. And so how do we solve these problems? Well, components to the rescue. So basically how this works with components to solve the problem is, instead of saying that everything, you know, is the different characteristics of this hierarchy, rather we abstract the different parts, the different behavior and characteristics like scratching and retracting claws and so on, and we create a component for it. Okay, so that's how we do it. So let's say I'm going to just kind of throw this over here. We have the same idea of an animal, right? So we've got an animal, and the animal still is going to possess the basic characteristics that all animals have, right? Like a location in space. This is kind of tying it into games a little bit more, right? So it's got some kind of location in space, you know, like GPS coordinates. It has like some kind of, you know, orientation, right? it's a real thing, and it can die, you know. So all the kinds of things that all animals possess, we still have that class, we still have that base object, right? So we still have it, right? So boop a doop a doop. Pretty cool. This is like a tombstone. It's like writing it out. It's what is it called? Epitaph. Okay, cool. And but instead of creating this inheritance structure, instead we create components, right? So in this particular example, and this is kind of like a strange example, but we talked about roaring, right? So it's a simple thing. So we have the roar component, perhaps. And so how the roar component works is, right, it can roar. And then I suppose there's like, you know, volume or something like that, like how loud this roar is going to be. Or, you know, let's say force, right? So that's a property, and maybe how loud it is and how strong it is and whatever have to do with the force. Cool, so we got this roar thing, and it's a roar component, right? It's decoupled from the animal. Roar is not an animal. It's just a component that an animal can add to its container, right? So when we're talking about a component, this is a component. And here is what you would maybe call a container, or often we will call it an entity. This isn't container divided by entity. This is like a container is also sometimes called an entity, right? It's the object itself. And a component is also an object, right? It's a class. It's like the roar class. But instead of it deriving from animal, it rather is just, we're creating an instance of that roar class, and we're referring to it here inside of our container, right? We refer to it inside of the container, and that's how we solve that problem. So let's say that we're going to create a T-Rex again, right? So how the T-Rex works is that the T-Rex is an animal, right? So it's actually deriving from this kind of container here. It is a type of that container. But it contains this roar component, okay? And anything that's associated with roar. Okay, so now it can roar, and the T-Rex might have other characteristics as well that you might find in dinosaurs, right? And it depends on exactly how you want to structure your game with what kind of components that you're going to create. And you know, I'm not going to go over all the different examples of components. You can try to use your imagination for the sake of time. All right, I want to also mention one other kind of major kind of gotcha with the traditional object-oriented model. And it's not the object-oriented model's fault. It's really just a way that certain novice programmers will often write code. And that is where they, instead of creating this kind of inheritance structure, instead they just throw everything into one class. So for example, let's say in this particular game, we have a dinosaur is the main character, and this dinosaur is called TRX. Yeah, okay, we'll go with that. And it's a pharmacist dinosaur. This pharmacist dinosaur runs a pharmacy or something like that, and has to resist the temptation to eat all of its patients. Okay, cool. So we got TRX, and TRX has everything in it, right? You're creating this pharmacy dinosaur game kind of thing. It's pretty cool. And in this game, right, so TRX has different things associated with it, right? Like health. I don't know why. Let's just say you got to put health in there, like, you know, just where we we pre decide before the game designer has even mentioned whether or not there's health. You just throw health in there, just, you know, for kicks. And TRX, let's say, has a name that the player character gave that T-Rex. And then all the other kinds of fun stuff, like, you know, score. We'll just throw that in the T-Rex class as well. And then T-Rexes can, you know, roar, so we've defined that. And the T-Rex can walk around, and the T-Rex, and then so in this walk around situation, right, so we have like a position, and so of course we then have to have position, and then the position can, you know, let's say position plus plus to keep it super silly. All right, yeah, this is actually also an infinite runner. Just position plus plus. And then what else about this stinking dinosaur? Also the dinosaur can play sound because let's say play sound, or let's use both different formats of writing this. Play sound, and when does play sound happen? Well, play sound happens when jump happens, right? You're gonna play sound. Something like that. And and we also have just other kinds of fun stuff, like render this T-Rex, right? So we got to draw the T-Rex, right? And then you also have to have an animate T-Rex, right? So you've got this animation stuff, and when do you animate the T-Rex, and when do you render, you know, how do you render the T-Rex and play the sounds for the T-Rex and all that kind of stuff. And this is what we commonly call in actually, just to really articulate the problem here, I'm going to try to draw a rectangle around it and see like how difficult it is to, whoa, look at that rectangle. See, don't do it for the sake of me having to draw a giant rectangle. No, it's what you often hear is called a monolithic class, right? It's this like humongous singular class that has all the different functionality and characteristics of some kind of object. Okay, so there's a lot of problems with this. One of the big problems is it's very difficult to maintain, right? So you've written like 2,000 lines of T-Rex code that contains everything in it. And so that's very difficult to maintain. And now you also need all sorts of different people working on it, right? So you've got these like audio programmers are having to come in here and tweak the whole like how play sound works, and you got the graphics people coming in and trying to like make sure that the rendering and the animation works for the T-Rex. And then you also have these like variables that have to be adjusted for like design purposes. So you've got this huge class that a lot of people are touching, which makes it very difficult to maintain for many different reasons, for source control. Also, for making sure that people aren't stepping on each other's toes. So that's one big issue, right? Just maintaining it and being able to read it and figure out like what is going on in each part. There's the other issue, which is code reuse. So if there's other types of objects that have health, or other types of objects that play sounds in a similar way or are rendered in a similar way, or maybe have collisions and they're treated in a similar way, you got that issue too, right? Because you got this giant class and you're gonna have to rewrite a lot of that code elsewhere. But should I be like numbering this down? So, oh no, not a note. Let's make it a note. Right, so we got one, we've got, you know, hard to maintain. And then two, we said that, you know, code reuse issue. And then we have other issues like execution order, right? So when you have all of this code in here, some things such as like what animation frame you're on, associated with whether or not you've walked yet, and all this kind of stuff, it starts getting jumbled together in this big knotted mess, right? And sometimes, especially when we're talking about threaded logic, where there's sound playing on one core thread, and then you've got physics or collisions on some other kind of thread in order to be able to make the game more efficient. Well, now you got huge problems in trying to get that to work in a singular class and making sure that you're not running into a problem where something is executing before you thought something else was supposed to execute. And so there's major issues there, even if you're not dealing with multiple cores. And creating a monolithic class like this puts you in a position, a dangerously close to what I like to call when your game is totaled, right? So a monolithic class and these kind of inheritance models, and really just any kind of code where your code turns into a huge ball of just horror. I like to sometimes say that your game is totaled, you know. And what that means is that you're introducing bugs faster than you're solving the bugs. Where when you solve a bug, you're actually creating 2 bugs. So like when a car is totaled, it means that your car is more expensive to repair than it is to just buy another one. Or to sell the car, right? So your car is worth less than the repair costs of the car. And that's the same with a game where your game is just now so messy that you're in order to fix the code, it's going to be longer and more arduous than to just rewrite everything with a better architecture. Okay, I also like to call that plow programming. Plow programming is where, let's say you've got this like plow. I don't know if you can picture this kind of thing. As you can tell, I'm a wonderful artist. Okay, you got like a plow. Is this what a tractor looks like? Anyways, we got this plow, and it's shoveling up dirt. Don't you love my sound effects? Very cool, and it's just kind of pushing dirt along. And at the beginning, you're just having so much fun. You're just plowing the dirt, making huge progress. Wow, it's like you look at this and you're like, at this rate, we're going to be able to plow the whole stinking field by sundown. Because you're measuring your progress of plowing at that moment. But then, of course, the problem that happens is that the plow, it becomes more and more difficult to push the dirt because you're not properly disposing of the dirt as you're plowing. You're just kind of pushing the dirt, and you're just hoping that it'll just kind of shove all the dirt like off into the neighbor's yard or something, and everything will be fine. Except then it's like your plow is now stuck because you created a mountain of dirt. You can't push it anymore, and your tractor is breaking, and motivation is going out the window, and everybody's angry, and you then write like a blog post on Gamasutra about how, oh no, this game was going to be amazing, and everyone gave us money on Kickstarter, and we screwed up, or something, right? So this plow programming is what is kind of the analogy I want to use when you just jump in and start writing stuff, and you're not refactoring often, right? So you got to refactor often to make sure that your trajectory is going to maintain without getting into a huge mess. Okay. So to solve this problem with components, it's the same kind of idea. So you have your T-Rex, but instead of, let's put this away. So you've got your T-Rex again, TRX, right? And TRX has certain characteristics that TRX possesses, right? Some things that are mostly trivial, like T-Rex's name, why not? And then some things that perhaps all of the components might have some kind of use, like position, perhaps, right? So like your collisions, your code, like the movement code and all that kind of stuff has to rely on position in some way. So we'll just expose that here. So position, the T-Rex possesses, which is fine, and that's generally simple and not an issue. But these other things where they don't really depend on each other at all is this kind of like audio kind of thing, right? So we have a component, and it's going to be called, you know, our audio component or something like that. And instead of having to write, yeah, let's just call it audio. Yeah, and then we also have our rendering, and we also have perhaps animation is like a separate component altogether. And so audio usually doesn't have to know anything about collisions. So these are all different components, let's say, and let's attempt to draw rectangles here. Rectangle, wonderful, rectangle, that, okay, we're going with it. Thank you. Beautiful. And then here we go. Audio is always tries to be weird, right? Just ask an audio programmer. Anyways, all right, cool, beautiful. And so T-Rex then goes ahead and adds all these components to this container. So this entity, this T-Rex entity, will go ahead and add each of these components. Okay, so pretty cool. And the wonderful thing about this is there might be other kinds of characters like NPCs, like what are other ones? Triceratops, so Trixie, which is a Triceratops or something like that. Let's go with Trixie, right? Anyways, and Trixie also, needs to be rendered. This other kind of object, it's like an NPC, and also needs to have collisions, right? So you got to check collisions. But let's say that T-Rex has something like player input. So just so we can differentiate here a little bit, so we got player input, and T-Rex is the player character, so has player inputs, and Trixie does not have player input, but instead has like perhaps like an AI controller, and that's separate. So the player controller and AI controller actually can both derive from the same class, and that would work. See, that would work with the inheritance model a little bit, where player input derives from, let's say, it's this like input controller class, and AI controller also derives from that input. Well, not input, I guess it would be just like a controller class, and they would share some similar characteristics. But AI would be controlled with your algorithms, and the player input would be through taking in player inputs, right? So there can be inheritance, and that's fine as long as they're usually pretty small in this kind of model and have very, very specific, not like extended in a way that just kind of is a runaway. So the takeaway here is that we are decoupling our code. So in this case, with walking and jumping and playing sound and rendering, it's all coupled into the same class. And the problem, as you can see here, is that perhaps like input and then jump, and so like movement and play sound, it's all coupled, right? So the takeaway here is we're talking about decoupling is what we're trying to do. Decoupling. So we want things to be loosely coupled. Oops, you can't see this, can you? We want things to be loosely coupled. And so when we look at this monolithic class, things are not loosely coupled at all. They're very tightly coupled. And that's where we create problems, where whenever we need to make an adjustment, we could accidentally break something somewhere far away in our code without even realizing it, because it's also tightly coupled. So the other issue that I was talking about with like execution flow, this solves the execution flow problem, because once you have all these classes together, you're able to loop through and perform the different things that each of these components need to do in the order that you need them to be doing them in. more explicitly. You can say kind of like update the rendering, update the animation, update the collisions in a specific order. But unlike our monolithic class where everything is just all kind of blended together. So it solves kind of that problem too. And it solves the code reuse problem, as we can see, because Trixie is able to use the same code for rendering, and you're able to kind of abstract that away from the concrete class example. So you're solving a lot of problems here by using these components. And that doesn't mean that there aren't problems itself with components. It's not going to solve all of your problems because, you know, there are other issues where sometimes you can't entirely avoid it, right? So there's animation and rendering, right? Animation and rendering sometimes are coupled in some way, right? So you can't just totally avoid it. And occasionally, if you want to be able to play a sound when the player lands on the ground, right? How are you going to be able to do that, right? In order to play the sound, you have to know that you're on the ground. And so how is the audio going to know when the player's on the ground if they are separate from each other, right? Or the other way around, how's the collision going to know? And so you run into those problems. And this is not the video where I'm going to be talking about how to solve all those problems, because we're going to be talking about other patterns that deal with those issues and how you can prevent just getting into the same problem where all your components are now communicating with each other, even though they don't need to be doing that, or need to be doing it in very strict particular circumstances. Okay, cool. That's what I got for you today. So that's all I got. And for those of you who have nothing better to do, you can sit here and watch me draw a T-Rex. See, so we got a T-Rex. It's got teeth, and it does this. Is that what a T-Rex looks like? I don't know. It's like, and how does it? It's really angry. It doesn't look that angry, actually. It's a happy T-Rex. All right, and then, of course, remember, this T-Rex derives from panthers. So here's its little panther ear. Beautiful. It's got 2 ears, of course. All right. You're still here? Oh, okay. Well, thanks for watching, and I'll catch you again some other time.